So for now, we have our model set. And right now we have to first declare a loss function that we would like to minimize. And then there is going to be the optimizer, which will help us optimize the parameters of the model, of course. This will be our Adam optimizer. But here we have to specify what parameters you like to optimize. So for that, all right. So now our loss function and optimizer are done. So now we can go to the training loop. So this will be our. So in the training loop, what we want first we want to iterate over the data loader. So for example, but we want to use the GPU. So for that, what we can do is we can do X. Because I have a GPU here, that's why I'm taking it to CUDA or to GPU. If you don't have, you just don't write this, you just write this much. And also there is one important part is the CNN model we have here. It has a lot of layers and some of the layer behave differently during the training and they behave differently during the testing or inference. So what decides that? So if you write CNN model dot train, then all the batch norm layer and dropout layer, they will behave as if they should during the training. And if you write CNN model dot eval, then it will do just the inference. It will behave like the inference is going on. And now we'll do the first forward pass. That means we'll pass our input through our model to get the Y pred. See, we got some error. Let's see what error we got and how we can fix it. Okay, so what it says, the input type and the weight type should be on the same device. That means I transferred my input values to my GPU, but I forgot to transfer my CNN model to the GPU. So for that, I have to write to CUDA. So now my model will be transferred to the GPU as well. So now we do not have any issues. And as both are in the GPU, they can interact with each other. That's fine. So we got our prediction. Now our goal is to estimate the loss. So for that, we'll write loss. So if I this printed the loss at the start. So once we got the loss, next our goal is to do the back propagation. For that, we'll just do loss dot. This basically does the back propagation for us and calculates the gradient for us. Next, we'll update the value of parameter. To update the value of parameter, we'll updates the value of each parameter. Basically, the value of parameter plus alpha, the learning rate, into the calculated gradient. All right. And there is one another important thing for PyTorch, especially for PyTorch. Other places we don't need it. That is to clear the accumulated gradients. So what does that mean? So this part is important because in PyTorch, whenever you calculate the gradient for each epoch, in the next epoch, it doesn't clear automatically. You have to manually clear it by doing optimizer.zeroGrad. Don't forget to do this PyTorch.zeroGrad. Otherwise, the gradient will keep on accumulating for each batch. This entire part is our training. If we just run it for so this will be for one epoch. Once they iterate through the train data loader, they do for one epoch. That means a one pass in our training data. But we want to do it multiple times. So for that, we need to write another for loop. We'll write, all right. So this is the training loop. Should be fine with this, but we want to go one step ahead. Yeah. Next, we want to write a test loop. And how do we write a test loop? There is one important part. As we are doing the testing, we have to keep in mind that we have to do CNN model dot eval. This is also very important. Otherwise, the layers they behave weirdly the layers such as batch normalization and the dropout layers. So we'll first calculate the loss function between the predicted and the actual the test lab labels. We'll put that in the running test loss item. So this will basically convert into a Python float value. We can do a print statement. For example, print. So to calculate the test loss for for the entire test data loader was to me. But we don't want to run this after every epoch. Maybe we'll do this after every second epoch. So for that, can do if we zoom out to see. This is a very simplistic way of writing a training loop in PyTorch. I hope you were able to understand the significance of each line and why we are doing it. That is important. Just like we did for the testing case, we can do a same running loss for a training data as well. So for that, now let's run it. Now let's run it for 10 epochs and see. But before that, actually the test loss doesn't give us a very good matrix. We want a matrix like accuracy, which we can confidently say that our model is this much accurate. Otherwise, if you go to a business person, they won't understand what does your test loss or a trend loss mean in the real business problem. They understand how much accurate your model is. So we should have a metric which keep track of what is our accuracy on the test set, whether it is increasing or not. So for that also we have a very nice label. It's called torch matrices. So if I write, and also we would like to send this estimator to our CUDA as well. So we are going to use that accuracy score that we defined just before the loop, and the input is we're taking the test spread. So what is this? Like, let's understand what is this part. See, this is basically the output. So each one represents it's the model's logit score before the softmax activation for different classes. So it's for the 0th, first, and the second. Dimension is the last dimension. So let's see what I got. So I got something like this. So right now they are basically the softmax is performed, and yeah, because we use softmax, there is no more negative values you can see, and they will add up to become one for each row. All right, so finally we are done. We've done writing our loop, and one more thing we can do is we can create a very nice progress bar. Because if I run this, it will go on running for let's say half an hour, but we don't know how much progress it's done. So it's a very simple library that often people use here. So we'll write, and yeah, there you go. Now it will create a very nice progress bar as we go. So now let's zoom out a little bit. This is our beautiful training loop that we just created, and now we'll just go ahead and run it. I'm just running it for 10 epochs, and we'll keep on monitoring the train loss, the test loss, and the test accuracy. So I will fast forward this part of the video. Solid. So our training is finished, and we can see that we got a pretty high accuracy, sometimes 99% to 98%. Yeah, and our training loss and test loss both are consistently decreasing. So this is a good sign, and we let's say with this we conclude that our training is finished. All right, guys, I forgot to tell one thing here that after we do the CNN model during the testing, we do in the inference mode. So we don't want to have any back propagation during this phase. So we'll write with this condition. If we write this condition, this CNN model will not track the back propagation or the gradients during this forward pass. But before, I would like to uh, tell one more thing, that is saving the trained model. All right, so it's a very handy tool if you know how to save the trained model, because you can't, with that you can do a lot of things. Suppose right now I train it for, let's say, what, like 10 epochs. You can again use the same model to further train it more times and get even better results potentially. So how do you save a model in PyTorch? So there are two main ideas, that you can save the entire model along with the architecture, or you can just save the weights. Just saving the weights is mostly preferred, but let's say we see both the approaches. So first of all, we'll see how we can save the entire model. For that, it's pretty simple. So torch.save is the way to go, and here we'll write which object we would like to save. In this case, it's our CNN model. CNN model we'll like to save, and what will be the file name? The file name will. So here you see we got the CNN model.pth saved here. The pth is the PyTorch way. And if you want to load the model, you just write torch. My CNN model is loaded back again. This is the simpler way, but so what is the recommended way is you save the weights only, not the architecture. So for that, we'll do the torch.save is still the same, but here instead of the model itself, we'll just write state dictionary. This text state dictionary contains all the weights. All right, and while loading, it will be a little different. Let me load it back and I see what is it. So this is an dictionary where if I write www.keys, you see I have all the layers, the weight that we just trained and optimized. We get the weights of them for every every layer. There are so many layers, and for every layer we have the convolution and everything up to the last one. Let's say uh, how is the last one? Just drag here. And you see the classifier one bias, classifier one weight. All right, so you just get the weights, you don't get the model architecture. But how we can use this? Okay, we saved it in a state dictionary, but how we are going to use it? That is also very simple. So for that, first we have to create the architecture that we want to load model in. And to create the architecture is very simple, very easy. We just go back here, this part, and we copy this part. Just copy it because this carries the architecture of the model. Yeah, and just paste it here. So right now our CNN model contains the architecture which is same as the weights saved here. So to load the state dictionary, so it executed and it says all the keys matched successfully. That means all the keys present in your weights matched to this particular model that you have created. All right. So these are two ways how we can save the model and load it back. And also we'll like to have dot. With that said, yeah, the saving and training model in PyTorch. Now we know. Next step is visualizing the result. So let's say we want to see the results in the test data set. So all right, let me see. What is this ypred? This is the ypred. If you write ypred.shape, we basically get the logic. So now we get the corresponding class values. And now let's see y test. So see, we see pretty much similar, like there is barely any error in this case. This is basically our labels, but we don't want this, like a 2-1. We want the exact label in terms of like oil, scratch, or stick. We can use list comprehension for that. So either we can write like So yeah, so now we got the corresponding classes, just with the list comprehension. So how we can do, we'll write, we got our predicted classes. And also, the for the true classes also we can do the same thing. Not only that, we would like to get the confidence. So what is the confidence here? So we got the class, but we want to know with how much confidence the model is saying it belongs to this class. For example, why Fred dot 99% sure that it belongs to the last class. So we want to have this number as well. But how do we get that? And to plug, I'll just write this code here. What it does is it basically iterates through each sample in X test. Then it shows that image using IAMShow, and then in the title it writes what is the predicted class, with what confidence it predicted, and what is the true class. So we can just show it, and so with this we get this is the predicted stain, true stain. We got 99% accuracy, 99% confidence. The model is saying it's stain. That's a good thing. Stain, stain, scratch, scratch, oil, oil. Yep. So yeah, they're pretty nice. Whatever the training testing we have, we got a pretty good result. So okay, so for this part of the video, that was it. We wanted to train we in a training script. We wanted to train a model just in a Jupyter notebook, and we did that. And along with that, we are going to put this whole model in a web app using Streamlit, which will be pretty interactive, and you can just upload an image and let the model decide which type of defect it belongs to and with what confidence level.